Hi guys, welcome back. And today we are going to explore p5Play, which is a physics engine, and also combining it with p5.js, which is what we usually code with in this channel. Let me just give you a brief introduction on p5Play. p5Play is a physics engine where you can create games such as these platformers that I've just created here. And all the physics properties are already defined, and the shape boundaries are also defined. So like collision detection, that's also defined, which is very useful for creating games such as this platformer that I created here. So let's take a dive in now. Okay, so now we're in, and before we begin, I just want to tell you that we are not using Replit because it does not have the p5Play module installed in it. And if you guys know how to install the p5Play module, please comment in the comments down below. And let's just get a basic introduction on p5Play before we begin. Okay, so now how do you load in a shape? Well, the shape in p5Play is called a sprite, which has a few parameters. So even though you can load it in without any parameters, it will just be at the center of the screen. But if you do load it with parameters, these are the parameters. So first is the x, then the y, then the width, and then the height. And remember, sprites take the center of the sprite like circles do. So that's how you create a sprite. And the width and the height, if you just define the width, it will give you a circular sprite. But if you define the height as well, it will give you a rectangular sprite. And of course, you can put in quotations on the, if you comma again and put on quotations, you can say like what shape you want, like hexagon, rectangle. I mean, rectangle's already defined, but you can call it like octagon or pentagon. Any of the shapes is all fine. Yeah. Okay, so now we have all the shapes here. Actually, it looks a bit like a woman carrying something. And we're done with the shapes. And now we can move on to how we color it and apply forces to objects. I mean sprites in p5Play. So how we can fill it is first, let's say we give one of the sprites a variable, and let's call it, this one's a circle, right? So we'll call it circ, which equals to sprite. Okay, then we can say circ dot color without the U, it's American spelling, and we can say it's red. So now the circle should be red, and no matter how many times we run it, it'll always be red. Then for the rest, we could always do the same and say rectangle equals to sprite. All right. Then you can say rec dot color, which would equal to maybe blue. So there you go. The rectangle is blue. I mean, it's more of a square, so I mean, you get it. So let's continue with the time lapse to fill each and every one of them. Okay, so now that we are done with the colors, now we can learn how to apply forces. And I've already pre-made them for you, so let's take a look at the forces. So over here, we have circ, ground, rect, pent, tri, hex, and oct, which are all of our variables that we use to color it. And I've also added this new thing called a ground. So this thing, if we run it again, is the ground for all the shapes, as you can see over here. And you see these things all fall down. This is because of world.gravity.y. You can always change it to x, and let's see what happens when you change it to x. It will all move that way. So, and then it'll be minus 10. So that means it'll be falling or moving minus 10 towards the 0. So if you change it back to y, it will all fall down. There you go. Now, since we've made it global here, I have put a few if statements over here that says if circ dot colliding ground, that means if it's colliding the ground, its velocity should go up by 10, and same for the rest. So if it's colliding with rect, pent, or tri, so you use this circ dot colliding, the circ dot colliding function to state that when it's colliding with the sprite that you want, something will happen to it. And in this case, the velocity dot y will go up by 10, but we can change it to x as well. So once it hits the ground, and then you'll see its x velocity will go by 10, or we can change it back to minus 10, which if it hits the ground, it will go that way, and it will go bounce up. So yeah, that's how you do it. And now I just want to show you one more thing, which is how we change the rotation, because this can be quite useful. So now we shall create a new canvas to try and see out how this rotation function works. Let's do it now. So now we're in this new canvas over here, and let's run it again. I've created a circle sprite and a ground sprite and applied world.gravity.y to be -5. So now we can show you how to do the rotation. So let's rotate the ground and say ground.rotation. Then you can say like -2 or something. It's equals to -2. There you go. Let's try that. As you can see, the ground is now rotated, and the circle should move down, and this is circle x. There you go. It moves again because I said over here if circle x circ x is greater than width, then circ dot x equals to width divided by 2, and circ dot y equals to height. So as you can see, it keeps getting faster and faster every time. And yep, that's how you create the ground rotation. If we run it again, it'll start like this. The ground will start to slope down. Alright, and this thing falls. And you can even make it to extreme cases and say that ground dot rotation equals to -90. That's, yep, like that. Or not, -91. And now it will fall through like that. Just fall down. So you could say 45 as well, which is actually quite steep. Through the hole, or you could say -10. But I think 45 is quite good. It's actually quite satisfying seeing it. Wee, 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 wee. And it keeps falling faster and faster and faster. So yeah, ground rotation is actually quite interesting. And that wraps up today's video. So thank you for watching and bye guys.